Homework 17, confidence intervals for population mean, standard deviation known, video 4. This is a continuation of the example from the previous video. The video had already gone into the 12-minute territory, so I decided to pause and just continue in the next one. Just to remind you what's happened so far, we are looking at the first example of constructing a confidence interval, where we are going to center an interval estimate at x bar by calculating a margin of error based on something called a confidence level. The confidence level represents the center area in a standard normal distribution, where the center is 0 and the numbers on the number line represent z-scores. In the last video, we figured out that if there is 95% in the middle, then there's 5% in the two tails, so 2.5% in one tail. We looked up an area of 0.0250 in the middle of the z-chart, went to the edges to locate the z. The z that we actually found was the -1, and the positive version of that is over here. The reason the one we found was negative is because we looked up a right area, but the z-chart tells us left areas. At the end of the last video, I mentioned that this is probably the hardest part of the process, using the z-chart backwards to calculate what are called the critical values, the z's that cut off the left and the right tail and leave the correct area in the middle. Your third step is to calculate something called standard error. Now, in this book, they do not give a variable specifically for standard error. In some books, the standard error is called capital SE. And I'm looking to see if they actually call it anything. Nope. I'm going to call it SE. But the formula for the standard error is one that we've seen already. It's the sigma sub x bar. Basically, it's the standard deviation of the sampling distribution of all the x bars. And recall that formula was sigma over the square root of n. So I really don't need this middle thing. I'm just saying that the standard error is the formula that we had already seen. In fact, because this book does not use capital SE for standard error, I think I will not use it either, and just leave the same formula that we saw in the previous series of videos. So what's our standard error here? Well, it's sigma, which is 1.5, divided by the square root of the sample size. I chose 225 because I know that it's 15 squared. So the square root of 225 is 15. And I don't need a calculator for this. I know it's exactly 0.1. Now, there's a chance, in fact, most of the time this will not be a nice decimal that just ends. So you should probably round it to the same number of decimal places as you have up here. I would go with more decimal places because you can just round to the end. You really want to be careful to round too much internally and wait until the end if possible. Now, this standard error is not our margin of error, but let me kind of explain what happens next. If you go way back to when we first talked about z-scores, z-score was the number of standard deviations from the mean. This is the number of standard deviations, this is the standard deviation in the sampling distribution of x bar, and our mean is our point estimate. So this z is the number of standard deviations from the mean. So we can calculate our margin of error by multiplying the critical value times the standard error. In other words, the product of these will tell us how far to move from the mean. So step 4 is to calculate the margin of error. And in this book, as I was looking through the pages, uses a lowercase m for margin of error. I can't bring myself to do that because lowercase m meant midpoint in another context. So I'm going to use the abbreviation that's used in other books, which is just capital M-E. And the margin of error is just the product of the critical value and the standard error In other words, the values that we found in the previous two steps. So if we multiply 1.96, which was our critical value, times 0.1, that will give us 0.196. That is the margin of error that we will use to open the interval. And remember, the interval is centered at the point estimate. The interval for mu is centered at x bar. So your fifth and final move, I'm going to erase the problem because I need the space over here. Oh, by the way, I don't think I actually said this earlier, but I meant to point out that our criteria were met. We weren't told it was a simple random sample, but normally you can assume it is, because if it's not, then it's beyond what we can do in this class. But it was worth mentioning that the sample size was large enough, it was at least 30, or it was greater than 30. So our fifth step in constructing a confidence interval is to actually calculate the interval. And the interval is of the form x bar plus or minus the margin of error. So our x bar was 2.75 plus or minus our margin of error, 0.196. And so we just have to do a subtraction problem and an addition problem and say that it's from this number to that number. So if we do 2.75 minus 0.196, calculator. 2.75 minus 0.196 is 2.554. And then if we add, instead of subtract, we get 2.946. And that is our 95% confidence interval. There is a way to interpret this. In fact, there's an easy way to interpret any confidence interval for a population mean. You just say the following. We state with 95% confidence that mu, in this context, the mean GPA for all students in a state, is between 2.554 and 2.946, which is equivalent to saying 2.554 is less than mu, which is less than 2.946. So we claim with 95% confidence that this is the interval in which our population mean lies. I want to briefly tell you what the 95% confidence level actually means. And in the next video, when we do another example, I will clean this up and hopefully convince you that this is a very straightforward process that is very predictable. Just do these steps and it's over. But here's what the 95% confidence level actually means. We are not saying that there's a 95% chance that mu is in here. Mu is not a random variable. It's a value. We just don't know what it is. It's either in this interval or it's not. So we can't say there's a 95% chance that it's in there. It's either there or it's not. What we can say, and here's what the 95% confidence level actually means. This interval was centered at this sample mean. Remember, this was the mean of a sample. The sample is what was randomly chosen. Had we picked a different sample, we would have had a different sample mean, and therefore our interval, although the same width, would have been located at a different location on the number line. Maybe it was shifted over a little bit, maybe it was shifted to the right. What the 95% confidence level means is, if we took every sample of size 225, we couldn't. There would be too many of them to do with the remaining time in the universe. But if we took every sample of size 225 and did this for them, we would have millions upon millions of different intervals. So think of this as being part of a number line. So let's go 2, 2.5, 3. Let's cut those in half. So 2.554 would be just a little to the right of that, and 2.946 would be to the little left of 3. And so imagine that this line segment represents this interval. What a 95% confidence level means is if we were to do this again for a different sample, which we centered at a different value, so instead of centered at 2.75, it would be centered somewhere else, but has the same margin of error because it would have the same critical value and the same standard error, therefore the same margin of error, then we would get a different interval, just as wide, but maybe split over a little bit. We might have one over here. We might have one a little bit further than there. It might stretch beyond 3, etc., etc., etc. Now, somewhere on this number line is the actual value of mu. Maybe it's here, I don't know. But what a 95% confidence level means is if we were to build every possible interval from every possible sample of the same size, 95% of them would contain the mu. This bottom interval, the one that I drew first and the one immediately above it, all contain the value of mu. This one over here doesn't. There's a good picture of this on page 367 where it talks about confidence levels and what's good and what's not good. But the idea behind 95% confidence is 95% of the intervals of the same width, but different centers, would actually contain the population mean. You see how long this video is running? So there's one more thing I want to say about confidence levels. It's 11:40, but I'll go ahead and say it because it's a short something. A quick comment about the confidence level. What's a good confidence level? 70%, 50%, 99%? Well, there's a trade-off with increasing and decreasing the confidence level. If you increase the confidence level, then you have more confidence that your population mean is in the interval that you have. But by increasing the confidence level, you're increasing the z, which increases the margin of error, which makes it wider. So for example, what if I said we state with 99.9% confidence that the average GPA is between -1 and 5? I'm more confident, but that's also completely useless because I knew it was between those because it's probably between 0 and 4. So the problem with larger confidence levels is they create larger margin of errors, sometimes so large that your results are meaningless. Sometimes we can get smaller margin of errors, but a smaller margin of error could be due to a smaller confidence level. So if I said a statement like, oh, you want a smaller interval? Okay. The population mean is somewhere between 2.73 and 2.77 with 10% confidence. I don't have much faith in your estimate if you're only 10% confident about it. So it's a battle between having an interval that's not too large and having a confidence level that's not too small. So what's a good confidence interval? Usually in the 90s. 90, 95, sometimes as high as 99, but below a 90% confidence level, you start getting smaller intervals, but you don't have much confidence in the results. You won't ever have to guess a confidence interval, you'll be given that confidence interval. I just wanted to point out that there are some pros and cons to raising the confidence level or lowering the confidence level.